Yeah, so we are going to discuss some common symbols. First of all, about sets. So as we know, this phi represents empty set, which contains no elements. This represents denotes an element belonging to a set. For example, element A belonging to set A means A is an element of set A. Clear?
Yes, sir.
Yeah. So, discussing about this symbol, this is just the opposite of the second one, that it denotes an element which is not belonging to a set. B not belonging to A, which means B is not an element of a set A. This now the difference between these two signs is that this is particularly used for elements. This is used for elements, whether this sign is used for sets. Okay. So this is the difference, and other than this, everything is same. So here A uh, is A is a subset of B, means every element of A is also an element of B, which is technically that A is the subset of B. This means, okay, so this denotes a subset or equal. This also denotes a subset. In this, we have also considered the equality condition. And now it means that A is a subset of B or A is entirely equal to B. So if it is the case, A is the same set and B is also the same set. Clear the difference? Any
Yes.
doubt?
No, no doubt, sir.
Okay. So this denotes union of two sets. Uh, A union B is a set of elements in which A, B, or both denotes. Means if we have to calculate the number of elements in A or B, then we will calculate for a cardinal set of this cardinal number of union set. Okay, this denotes intersection. A intersection B is a set of elements common to both A and B, and is a necessity condition that that particular element must be in A and as well as in B. Okay, now this, yeah, I used to get confused in exams whenever it was written like this, probability of this. So it basically means A minus B only. Okay. This reverse slash, whatever this is called, A reverse slash B is the set of elements in A, but not B. So it is similar to writing this A minus of B means A minus A intersection B. Clear?
Sir, many examples.
Yes, let me simply write it. Do you remember what is this? Like if this is set A intersected by set B. So A minus B means A but not B. So B should not be considered and whatever left in A will be considered. This part. Clear? So we can also write it as we are subtracting the common area between the both sets like this. Okay? Clear?
Yes, sir.
This clear. So now this other representation of difference between two sets can be written like this. It is equivalent to writing this. This is the only point. Clear?
Yes, sir.
Now this denotes symmetric difference. A del B is a set of elements in either A or B, but not in both. So in this, if there are two sets A and B, we are considering all the sets, but not in both. So the intersection part will be left out. So A minus B is this is unified with B minus A. And it is A del B. Clear? This one is clear?
Yes, sir.
Yeah, P of A simply denotes the power set, which is a set of all subsets of a particular given set. So if you have to find out the cardinality of a power set, what is the formula? Given that the number of elements in n of A is n. What are the total number of subsets of a set having n elements?
Mm,
No, but do revise your notes, okay?
okay.
Let's discuss about relations. So A comma B, it is an ordered pair, denotes an ordered pair. We are going to discuss this in today's class. And R is a subset of A cross B. Now, what is this? This is A is a set and B is also a set. And the product of two sets is known as Cartesian product. Okay. So, and the subset of the subset of Cartesian product of two sets is relation. Let's discuss the relation first, then we'll be able to understand this further. And let me do it. Okay. And you'll be able to connect the dots better after discussing relations. So it means A element is related to B element by a relation R, which is there. This denotes equality, this is inequality, this is less than, this is greater than, this is denotes less than or equal to, denotes greater than or equal to function. A function denotes a function from set A to set B. These both are sets, and set A is domain here, and set B is range here. Domain and range. A function is this is a function from domain to range, which is set A here and set B. Okay. So the function set will be written as this, where A is an element of domain and B is an element of range, which is B. F of x is denotes the value of function at element x. Domain of this denotes domain. This denotes codomain. Codomain is set of all possible outcomes. Codomain, you will be able to understand it better, but let's just look at it. Key denotes the codomain, and range and the codomain are different. Okay, there's a difference between codomain and range. Codomain is the set of all possible outputs, and range is the set of outcomes. Im of f denotes the image of a function. These three are not much used. F of g means denotes the composition of functions f and g. We are also going to discuss this today. F of inverse means the inverse of a function if the function exists, and if the inverse exists. Basically, what happens in a inverse of function, that the range which was earlier, it becomes the new domain, and the domain which was earlier, it becomes the new range. This denotes, this is important, this denotes for all. Okay.
Yes, sir.
This denotes there exist. Full tie. Let's go to the slide. Is the screen visible?
Yes, sir.
So we have discussed about sets in the earlier class. Now let's discuss about ordered pair. The two elements A and B listed in a particular order is called an ordered pair. It is denoted by A, comma B in small brackets. In an ordered pair, A is regarded as the first element and B is regarded as the second element. So, and so this is an ordered pair. This must be belonging from set A. This must be belonging from set B. Means not particularly A and B. That's why I'm writing A and B. No, these are the sets and these are the elements of that set. And so this is, it is evident from the definition that in an ordered pair, these two ordered pair, like these two ordered pair, are not equivalent. They are different. These two ordered pairs are different. They are not the same. Okay. This is what written here. And second thing, that A, B, if two ordered pairs are equal, so this particular value will be equal to this particular, and this particular value will be equal to this particular. So A is equals to C, B is equals to D. Is that clear about ordered pair? What is an ordered pair? So this is an ordered pair.
Yes, sir.
Yeah. So let's now understand Cartesian product in U, and here is the application of ordered pair. So what is happening here is there are two sets, you know, and let's understand from the mathematical application first. There are two sets. A and B are sets, and if we are multiplying two sets, then it is known as Cartesian product, and its result will include all the elements. Like it will include ordered pair in such a format that A can be any element from set A and B can be any element from set B. So this is basically what a Cartesian product set is set looks like, and this is a set builder form. So let's try to make a set by ourselves, and then we'll be able to understand what is the Cartesian product after using it. Let's take A as a set of vowels and B as a set of numbers, 0 and 1 binary numbers. So now if we have to write A cross B, the Cartesian product of A cross B. So as you know, the first element will be can belong from the, should belong from the first set, any element. So let's take A first and any element from B. So let's take 0 first. Now let's take A only, and as 0 is already used, so no, we cannot repeat the ordered pairs. So A, we have already taken 0 with A, so let's take 1 with A. Now, there is no other value of B will be possible from set B along with A. So let's now take E is the first. Now 0, E, 1. So you must have got the logic. Okay. un1, and that is our Cartesian product set. Okay, so what we are doing, that the first element can be any element from the set A, and the second element can be any element from set B. It's the only condition that there can be two, there cannot be two same ordered pair in the Cartesian product. Like we cannot write A1 twice because it's already there. So no use of writing this again. Clear? Any doubt? Let's take one more
Yes, sir.
example. Let's take second example. It is more easy. So example number 2. So we have a set of colors, that we have two colors in our set, red and green, and the other in other sets we have shapes. These are shapes, circle and square. So if we have these two sets, like if we have these two categories of material, we have like we have lots of material of two shapes, circle and square. We have lots of material of two color, red and green. So when we material, not this is like paint color. These are shapes that we have. So what kind of different activities, what kind of uh, different elements can be made out of them will be represented by the Cartesian product of these two sets. So we'll take first red, and then the first shape circle, and then the red and square. Okay, and nothing is left with red then. Let's take green with circle. Okay, green circle. Let's take green with square. Green with square. Okay, got it. Now, how is the Cartesian product formed from two sets?
Yes, sir.
Yes. And now if we just look here, let's take this example more. Then let's observe something about the Cartesian product. Yeah. Looking on in this example, we have set A of numbers 1 and 2. We have set B of alphabets A and B. So we can take one with A, one with A, one with B. Okay, one with B, done, nothing else. Two with A, two with A, and two with B. Okay, so these are like four elements. This is one element, separated by comma. This is second element, third element, fourth element in the Cartesian product. So if we observe, the number of elements in Cartesian product is given by this formula. Correct? Hmm. Okay. So given by this format. So here there were two elements in set A, two elements in set B. So 2 into 2, 4. Yes, 4 are there. And considering this case, there were 5 elements in A and 2 elements in B. So there must be 10 elements here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is the case. Two here, so 4, 1, 2, 3, 4. So yes, this is one case. Now, if we try to find out the Cartesian product set from set B to A, so what will happen? Please tell me what is the Cartesian product here.
A comma 1,
Yes,
A comma 2, B comma 1, B comma 2.
we are so fast. Okay. Hmm. So B cross A, it is different than A cross B. Is it so? Nice. Is it so?
No, they are same only, sir. Only like A is in the second place and one is like only the places are interchanged.
Okay. Is lost. Wait a minute. Okay, 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 okay. Now, let me write it again. N of A cross B is N of A into N of B. There was 2 into 2 was 4. So now, considering here, B is AB and A is 1, 2. And B cross A is A1, A2, B1 and B2. So now comparing these two sets, A cross B and B cross A. So are you saying, are they the same? Like 1A is equal to A1.
Hmm.
A1 is equals to 1A. Is it so?
E1 is equal to 1. No.
Because no, because in ordered pair, order matters. Because
Yeah, yeah.
the term itself say ordered pair. So that is why these are two different. So the commutative property is not true here for Cartesian product. So after observation, we have found out that the number of elements in Cartesian product of two sets is equal to the product of the cardinality of two sets. This is the point. And Cartesian product of A to B is different than Cartesian product of B to A. Okay.
Yes, sir.
So let's now discuss about some facts related to Cartesian products, like the properties. Okay. So 1A, A into B union C is equivalent to A cross B unifying with A cross C. So it's like you can remember it logically that this is this, the union sign is coming out, then this is this, A cross C, A cross B. Okay. Similarly, A cross B, A cross B, then the intersection sign, then the intersection sign, then A cross C, A cross C. Clear?
Yes, sir.
Yeah. And similarly, same concept here also. A cross B minus A cross C, A cross C. A cross B is equal to B cross A. That is, acha, acha, acha. I was thinking, how is it possible? But it is, this is not a property. This is saying that if if A cross B, this is saying that if A cross B is given as equal to B cross A. Wow. There is a if then condition here, which is bidirectionally true. Let me save the file first. Yeah. So it is a if then condition here that if A cross B is given as being equal to B cross A, then A must be equal to B. Then only it's going to stay true. And also, if it is given that A is B, then A cross B can be written as B cross A because they are equal. Okay, so are you able to understand this point? Clear?
Yes, sir.
And remember, this is all Cartesian product of two sets where A, B, C are non-empty sets. Coming to fourth point, if A is the subset of B set, then it is evident that we can write A cross B, the Cartesian product of both of these, and the Cartesian product of between these two sets is going to be a subset of the intersection of A cross B and B cross A. If A is the subset of B. If A is the subset of B. So I think we should take an example for this to understand. So for taking examples where conditions are given, we have to, even if we are assuming any variable in any given question, then we have to satisfy the given conditions which are related to the variable that we are assuming. So here we are going to assume A and B. So it is given that A is a subset of B. So let's take B set first. Let's take B set as I, and A set as small only. Let's take as A only, single digit. So yes, A is the subset of B. True. Now it is saying that A cross B. Let's find out A cross B. A, A, E, A, I. This is A cross B. Is a subset of A cross B and B cross A. B cross A will be what? Will be A cross A, E cross A, I cross IA. Sorry, not cross. AA, EA, IA. So now the intersection of both these two. So now the intersection of both these two is what? Please tell me. What is the intersection of these two sets?
Mm.
These are three
A,
elements.
A comma A.
Yes. This single element is the element of this particular set. Now, it is said that A cross B is the subset. A cross B is what? This is the subset of A, A comma A, which is not true. Which is not true because A cross B is a bigger set. And how it can be the subset of a set which is having only one element? No, this is untrue. Or this may be a misprint. So let us check and takes reference from some other book. Let me check it. Till then, you check, have I done any calculation mistake or any conceptual mistake? Must be a mistake. Fourth property. Going to consume time.
So then this is like the answer is not coming, sir.
What?
Now for that property,
Ah,
like whether we are not getting the exact thing or
no, actually, I have a problem in understanding the property, and I think it is untrue.
oh,
Yeah, as per our example that we have just discussed.
mm.
Okay, okay. Let me screen share. It's untrue. And why it is given in the book? Maybe a misprint. So they have also, ChatGPT has also taken, they have first given the definitions and then taken an example. And this property is not true in general. So let's discuss their example. They have taken A as 1, B as 1, 2. So here A is the subset of B. So the Cartesian product is 1, 1. Let me annotate. So the Cartesian product here is 1, 1, 1 and 1, 2. 1, 1 and 1, 2. Okay. 1, 1 and 1, 2. And for B cross A, 1, 1 and 2, 1. 1, 1 and 2, 1. The intersection of both of these is this term only, the common term. Now it was mentioned that A cross B must be the subset of A cross B. This, so A cross B was a bigger set, having everything. So that's why A cross B is not the subset of this particular set, which is having only one element. Okay, so that's why this property is not true in general. Okay, clear? Any doubt? Are you able to understand this? That why are we saying that A cross B is not the subset of this? Let me write what is A cross B. This is, and what we are saying here is that A cross B, this particular big set, is the subset. This is a subset of this is what we have find out. So can this be father of this A cross B?
Which one, sir?
Can this particular set, which we are according to property, it was mentioned that it has to be true that this particular set has to be the subset of this. Is it so? Like what is a subset? This is a bigger set, like this is the superset for this particular set, which is available inside it, and this is known as the subset of the set A, and let's call it as B. So B is the subset of set A. Now A is the superset. Now according, and how we represent it, we write B is contained in A, means B is a subset of A. Now here, as you can clearly see, that this particular set is bigger than this set. So, and even it is not getting completely included in this set. That's why we are saying that this particular set A cross B is not a subset of this. Clear?
Yes, sir.
100%.
Now the 1 comma 1 is actually a subset of that.
And it is written in reverse.
Okay.
Yeah, maybe it's a misprint. Let's go back to slides and define both property. If A is a subset of B, Cartesian product of A and C is also a subset of Cartesian product of B and C. Basically, we have multiplied C on both sides of the symbol of subset. Okay, so
Yes,
this is
sir.
a property. A is a subset of B and C is a subset of D, is equivalent to that A cross C is a subset of B cross D. So left side product, and right side right side. This is another property. Clear?
Yes, sir.
Now A cross B intersection with C cross D. So we may write it as A intersection C and B product with B intersection D. Clear? A intersection C and B intersection D, and the cross will come in between them. Clear? Any
Yes.
doubt?
No, no doubt, sir.
These are all properties. These will like look like vague, but when we'll solve examples, be able to understand them more clearly. As here, there's like complements written, so union will turn into intersection, and the remaining property will stay true of as of the 1A property. Clear? Because of complement, the intersection change into union. Sorry, the union change into intersection, and intersection change into union. Both properties clear?
Yes,
There
sir.
is a logic how to learn them.
Hmm.
For 10th, if any elements are common in A and B, means if this is n, then in A and B and B and A, n square elements will be common. So if it is the case, then n of A cross B intersection B cross A, the answer will be n square. Clear? Now should repeat that if there are n common elements in A and B, then there will be n square common elements in the intersection of the Cartesian product of A and B and B and A. Now clear? Any doubt?
No doubt, sir.
Let's now discuss relation. So we have discussed about Cartesian product, and also you yourself have to take your call that which property I need to remember and which property I just understand. Okay, and you will be doing so after solving a lot of previous year questions. You will yourself get to know that which property is getting used much and which is just not getting used, and we can just understand that property and we'll get our work done. Okay.
Yes, sir.
Yeah. So let's now discuss about relation. So if there is a set A, sorry, there is a set A of 1, 2, 3, set B of 1, 3, 4, 9, and bus, and 2 also. Okay, let's see that. So this is the set. So A cross B is what? Please tell what is A cross B?
1, comma 1, 1, comma 3, 1, comma 4, 1, comma 9,
Let's start with 2, 1, 2, 3.
2, 3, 2, 4, 2, 9, 3, 1, 3, 3, 3, 4, 3, 9.
Yes. So 3 into 4, 12, 1, 2, 3, 4, 4, 8, 8, 4, 12. Yes. So this is the Cartesian product. Now, if we particularly select few elements from this Cartesian product, let us say if we are selecting this, okay, no, this and this. So let's call this particular set our selection set, as it is selected by me. So let's say name it as S. Right, S, more beautiful. Okay, what is your selection? 1, 1, 2, 4, 3, 9. Now, do you agree S is S a subset of A cross B?
Yeah,
Yes
that's
or no?
equal to symbol now, sir.
But it is yeah, okay.
And then it is a subset.
But this is the representation of subset. That's why we
Mm.
write it like this only. Okay.
Okay.
So here we can say S is the subset of A cross B. So now S as a set is known as a relation from A to B. And how we can write S particularly? Like if we have to write this set, this is the roster form, where we have elements. Now let's write S set as in set builder form. So what is the pattern? How we can do so? What is the pattern? How, like when I'm asking about the pattern, how is this element is related to this? How is this element is related to this? How is this related to this? Is there a common pattern?
Uh, 2 and 4, like they are multiple, and 3 and 9 is also multiple. There is
Okay.
a like 2, 4 means
2 is getting multiplied 2 times to get 4.
ah
3 is getting
3
multiplied
times
3 times.
to get 9. Yeah.
There must be some common relation which we can like use for all three elements. Now here it is getting 1 time multiplied, 2 time, 3 time. There must be something common. Observe. I'm just asking about the relation, how this is related to this. And that particular relation must be common in all three elements. That's how we will be able to define it.
No idea. Are they natural numbers, or are they like 4 is multiple of 2, 3 is multiple of 9? Like I don't know.
Now,
Square. Okay. Square. 2 square means 4. 3 square means 9. Okay.
got it?
Yes, sir.
That's how we are going to write this particular set in set builder form.
Oh.
That the first element is the square root of the second, or the second element is the square of first. And the first element, for all first element belonging to set A, for all second element belonging to set B. Now, clear?
Yes, sir.
Now this is known as relation. This is known as relation, which is our next topic. Good introduction, huh? Okay, are you able to understand it? That what we have done, there were two sets. We have taken its Cartesian product, and we have chosen some elements from the Cartesian product. And if we have chosen all the elements from the Cartesian product itself, then the formed set is definitely going to be the subset of Cartesian product. And any subset to the Cartesian product of two sets is a relation. is a relation from set A to B. Okay, so this is the definition of relation,
Yeah.
whichever is included in the box. This one. So let's now read the bookish language. Let A and B are two known empty sets, then a relation known empty sets. Okay, then a relation R from A to B is a subset of Cartesian product of these two sets. Equivalently, any subset of the Cartesian product of these two sets, A and B, is relation from A to B, because the Cartesian product is the A is written first. Otherwise, would it have been written like B into A? Then the relation will be from B to A. Thus, R is a relation from A to B, and it is equivalent to writing as R is the subset of Cartesian product between these two, and R is the subset of Cartesian product. Cartesian product can further be written like this. Do you agree? Where A can be any element from set A and B can be any element from set B. And what different we have done here is that we have put it a relation. That's why this has become a relation, but not a Cartesian product. Okay. Are you able to spot the difference? Now, this relation is not, it is not equal. Relation is the subset of Cartesian product. Here we have written relation that which is represented by letter S is equal. This is like the particular set of relation. Okay. How it is different from A cross B? Because there is a relation. Otherwise, अगर हमें A cross B लिखना होता, so we will write it as xy such that x is belonging to no. Okay. xy for all x belonging to A set and y belonging to B set. So what's the difference in between these two? This is the Cartesian product, this is the relation. This particular is the difference, which is the relation. Okay?
Yes, sir.
Yeah. So relation is basically a set which is the subset of Cartesian product of two elements, of two sets. Okay. If AB belongs to R, then we may write A is related to B, which means that A is related to B by the relation R. If AB does not belong to R, then we may write that A is not belonging to B. This is the misprint. Then and we say that A is not related to B by the relation R. So this is just the representation explanation that if it is like so, it is equivalent to writing where R is the relation. Okay, and it is equivalent to writing. Clear?
Yes, sir.
Yeah. So if we go back to our relation S, so if we take the first elements and make a set of them 1, 2, and 3. So this is known as domain of the relation because they includes all the first elements. Let me save the file. And if we take the second element, if we take the second element from the relation, then that particular set, okay, domain, we take the whole first elements 1, 2, and 3. If we take second element 1, 4, and 9, so this will be the range of relation. Oh, please work. This is the range of relation. Let's read it here. If R is a relation from set A to set B, then the set of all first coordinates of elements of R is called the domain of R. While the set, thank you, while the set of all second coordinates of elements of R is called the range of R. Okay, so here it is a little bookish language. You will be able to understand it after you have made conceptual clarity. Here you can simply understand it that the relation, the set of relation, which was this represented by S, the first elements, if we collect all the first elements and make their set will be known as domain. And if we collect all the second elements and we make their set, then it will be known as range of the relation. So it is the same written here. The domain A belongs to set A, AB ordered pair must be belonging to the relation for some B belonging to B set. It is the same also here. And where we have taken we have taken the set of B elements, like the second elements, and we have taken the set of first elements. Clear? Any doubt? Any
Yes.
doubt about domain and range?
I have a doubt on domain, so could you repeat it again?
Ha. Okay, should I repeat it?
Yes, sir.
Yeah. Okay, so let's take one more example. Okay, let's take a set, A set, 1, 3, no, 2, 3, 5, 7, and B set as B is a set of natural numbers. Okay, all natural numbers, which are 1, 2, and going on. Understood? Clear?
Yes, sir.
Yeah. And there is a relation. Okay, let me read the definition. There have to be two non-empty sets. So I have to, so this is non-empty set. This is infinite set, but this is non-empty for sure. Okay, so I can take this. So relation is 2, 4, 3, 9. Let's take some different relation this time. Let's take, so let's relate the set A and B with as X relation XY such that X must be belong for all X belonging to, have some space. We are taking a relation in which we are taking XY such that X must be the X must be equal to the cube root of second element. Why is the second element here? For all X belonging to A and Y belonging to B. So do you have any confusion in how have I written so? Like what are the symbols represents?
No, symbol, no, sir. I don't have doubts in symbols. X is equal to y cube, that part only.
So that's like I'm building a relation by myself.
Okay, okay.
It's an example.
Okay, sir.
It's not sure that this is only going to be the relation. Relation can be of different nature. There's
Okay, okay, sir.
any relation. Yeah. So how we will make the set here? So 2 is 2's cube 8 is 8 in. So let's go step by step. So as it is written here that we can take any x from set A. So let's take set x as 2. Okay, 2. So its cube is 8. So is 8 available in B as per our question? Because we have to be in restrictions as per the given relation. So y has to be in B. Y here is 8, right? 8 here is 8, 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 No, I have
Uh,
made a mistake. I have made a
by
mistake.
cube you have wrote, sir.
I have made a mistake in writing here.
Okay.
X cube is equals to y. And going back, let's check that. Here also. Thank you for having doubt. Yeah. So if x is 2, y should be 8. Now is x is belonging to A? That is for sure because we have taken from A directly. Is 8 available in B? Yes, it is. So it would be in our relation set. Okay. Going for the next element, 3. 3 is cube, 27. Is 27 a natural number? Yes, it is. 5. 125 a natural number? Yes. 7. 343 is a natural number? Yes, it is. 49 into 797 is 3. Yeah, it is the case. Yeah, so this is our relation. So what was your doubt? Now domain. Now domain of this relation, and now this relation is from A to B. Why A to B? Because the first element is taken from A set. That's why this relation is A to B. So A is related to B as an element, A belonging to set A and B belonging to set B. Relation from A to B. So domain of R is the first elements here in the relation, which are 2, 3, 5, and 7. And range of this relation are 8, 27, 125, 343. The set of second elements. Clear? How have I written the domain and range? Any doubt?
No doubt, sir.
Okay. Now let's discuss about codomain. If R be a relation from A to B, then B is called the codomain of relation. It does not depend whether the relation have something or not. It's just that if relation is from A to B, then B is the codomain, A is the no. B is the codomain. Simple. And range was this the collection of second elements from the relation. The collection of first elements from the relation is the domain. Any doubts? Here, what is the codomain here in the relation? The codomain is the whole set B, which is the set of natural numbers. Clear?
Yes, sir.
Let's move. Okay. So if there is an empty relation, if there are no elements in the relation basically, so it will be known as a empty relation. Clear? If there are no elements in a relation, then it will be known as a empty relation.
Hmm.
Discussing what universal relation, if there is like if we are discussing if we have taken the Cartesian product of a set on itself only, and we have taken the subset of this complete set, like the complete Cartesian product, as we are discussing about this relation. So this will be known as universal relation because the condition of equality is existing here. It's not just a subset. It's just not a subset. Yes, it is a subset, but it is also equal to the other set. Okay, so that's why it is known as universal relation.
Yes, sir.
Identity relation, whenever there are when like if a set has 1, 2, 3 elements in it, and we are discussing about the relation from A to A only. A to A, when we are discussing about from A to B, so the Cartesian product, this was considered. Now A cross A will be considered. So if this relation includes only 1, 1, and 2, 2, or 3, 3 elements, only these 3 elements, then this will be known as it. Oh, I have, there's already given example. So if there is a set given like this and the relation having 1, 1, 2, 2, 3, 3 elements only, then it is going to be identity relation. My point is, whichever element was there in the given set, it is just repeated, and these are the only elements in the relation, then the relation will be known as identity relation. It's repeating its own identity. That's why. Clear? Any doubt?
No doubt, sir.
Yes. No doubt. Okay. Inverse relation is simple. We have just, if there was a relation written like this, so inverse relation is simply the domain, which was 1, 2, 3, will be written in this as in the form of second element, and the range. This was the domain. This is the domain. The range 1, 4, and 9 will be written first. So what has become in this particular relation? What is the domain? 1, 4, and 9 for this particular relation. And what is the range? 1, 2, and 3. This is the range. So the domain for R inverse is the range of the R, the first relation. And the range for this relation was the domain for the R relation. Got it? Simply we have inversed B and A, okay, in place of A and B. So it has reversed. This is the inverse relation. Simple. Clear?
Yes, sir.
There's a point to consider. It will only happen in certain scenarios. It may not happen always. Why? Maybe like if in relation there's a point minus 1's whole square is 1. This is the relation maybe that x square is equals to y. But if we have to write its inverse relation, then what? First consider this. We have to write its inverse relation. Then what will happen is x will become square root of y. And now if we will interchange the position, y is square root of x. So considering here, finding out y, square root of x minus y, is it equals to, this is equals to iota instead of 1. That is why. Let me rewrite it simply. This was the relation, okay, where the second element, where the basically second element was the square of first. So if we inverse it and write it as this, so here the second element is minus 1 and the first element is 1. So is the square of first element equal to second element? Is it so?
Mm, no, couldn't understand, sir.
Okay. Okay, we will let's discuss it today only.
Ah,
Take a new page and new color. Okay. So we are taking a relation. We are taking a set. Let's say 1A includes these two elements. And we are discussing a relation from A to A only. So A cross A minus 1. So how we will find A cross A? We're writing it twice. Minus 1 with minus 1. Okay. Minus with 1, 1. 1 with minus 1. and one with 1. So we have not repeated any. Yes, we have not. So let's take a relation. Let's choose some elements from the Cartesian product. Let's choose in the pattern that where the first element. We are writing x as the first element. This is the first element. This is the first element. Okay. Y is the second element of the ordered pair. Simply learn them by this. So we are finding out for that the second element must be equal to the square of first. Okay. So let's take the first element as minus of y. The square of minus y. The square of minus of 1 is 1. Is 1 available in the is 1 available in the right as in the second element in the Cartesian product minus 1? No, 1. Yes, it is available. Taking 1 square. So is 1 available? Yes, 1 available. Anything else we cannot take. So this is the our relation. Okay. If we have to find its reverse relation, so according to our learned method, we have to just reverse the numbers. So now, but here the inverse relation is not going to satisfy because we find out the square of first element, the square of first element, 1 square is not going to equal to minus 1. That's why this relation will not be formed. Here inverse relation will not exist, or if it would exist, then the y should not be negative here. That's my point. Okay. And even if you are not able to understand it, we'll discuss in examples. Okay. So is that clear? Is that
Yes,
clear
sir.
that anything square cannot become negative? 1 square is not negative 1. Do you agree 1 square is not minus 1?
Yes, sir. 1 square can't be minus 1.
Yeah. So here also x is the first element. X is the first element. Okay, 1 square. And as per your relation, its square is equals to be minus of second element. Sorry, is equals to second element. Second element is minus 1. Is it true? No, it is not. That's why this particular relation will not exist. Because this is not satisfying our relation. Okay?
Yes, sir.
Is the case. We'll discuss further in tomorrow's class. Any other doubts from today's class?
No doubt, sir.
You want
Okay.
to move from a household brand to an international brand.